welcome back to the National 5 Maths course. In this lesson we're going to look at an almost feared topic of National 5, and that is indices. Indices are often feared just because of the rules associated with them, and it can get a bit complicated, but with the logical way we're going to look at it, it shouldn't be too hard. So I'm going to start off by saying some things you should already know how to do before starting indices. This is how to find the square, cube, and square root of a number, how to add, subtract, multiply and divide decimals, how to add, subtract, and divide fractions. If you don't know any of those, or if you're stuck on one of those or a few of them, that's fine. Just go check some of our lessons on them. And if they're not included in this course, maybe just because you haven't practiced them so much, that is fine as well. Just make sure you practice those as well. But if you're a bit rusty on them, don't worry, because we will kind of be covering it in this lesson as well. Just make sure you know the basic idea of these. So indices is just the plural for index, but this isn't something you really need to know. So, for example, let's look at how this works. So we already know that writing 7 squared is the same as writing 7 times 7. This base number here multiplied by our indice, or our power, illustrates how many times. 7 times 2, or 7 to the power of 2 even, definitely not 7 times 2. 7 to the power of 2 is just 7 multiplied by itself twice, and then 7 multiplied by itself 3 times. This is what we call the base number, and then here are our indices, 2 and 3. So again, this would just be 7 to the power of 52, 7 to the power of 52. Now, looking at our first rule, and this is where it gets a bit tricky, so just make sure to pay attention. The first rule you need to know anything about is that anything to the power of 0 is always 1. So any number, so even if it's not defined, even if they don't tell you what it is, if it's a to the power of 0, it's 1. If it's x to the power of 0, it's 1. If it's y to the power of 0, it's 1. Doesn't matter if it's a letter that you don't even know the value of. Anything to the power of 0 is always 1. So this is quite a simple rule. 1 to the power of 0 is 1. 622 to the power of 0 is 1. So just every time you get that, just remember it's always 1. Anything to the power of 0 is 1. There is one exception to this rule, and it's 0. 0 to the power of 0 is not 1. 0 to the power of 0 is undefined, but we don't need to go over why that is. Just remember, so even if it's a, or x, or y, or z, anything to the power of 0 is always 1. So, now that we know rule 1, let's go ahead and look at rule 2. And by the way, the whole point of learning these questions, or learning these rules even, is because you have to use these rules in questions. In this lesson, we're looking at the first 2 rules, and in the next lesson, we will cover the remainder of these rules. So, our next rule is a to the power of negative m is equal to 1 over a to the power of m. So basically, to make this power positive, we have to put on the bottom of a fraction. So this rule catches a lot of people out as they are unsure what goes to the bottom and what needs to stay at the top. So I'll show you an example of the easiest way to decide what stays at the top and what needs to be moved. So here we have, and again it's just another example, b times by negative 4 is just equal to 1 over b to the power of 4. And again, same thing here, 4 to the power of negative 2 is just equal to 1 over 4 squared, which would just be 1 over 16 as we know. So now looking at kind of a more complicated example, as this is where a lot of people go wrong. A lot of people assume, because of the rule, and it's a logical train of thought, that a to the power of negative b goes into, or this goes into this, where the 2 goes to the bottom as well. However, this is not correct, and it catches a lot of people out, even in a lot more advanced levels of maths. People way above this level often make this mistake, so it's something you need to watch out for, and hopefully just get good at now to avoid doing it in the future. So the first thing to realize is that the only thing we're doing is putting a to the power of negative b, not 2a to the power of negative b. If this 2 was in the brackets with the A, then yes, this would be the correct answer up here. But it's not. It's separate things. We have 2 multiplied by a to the power of negative b. So we must separate it into 2 kind of separate terms. The rule only states a letter multiplied by a power. So this is what we do. We separate this. These 2 things here are exactly the same. 2 multiplied by it. But put this in our separate brackets, and then once we apply the rule, that will give us 2 times by, and then 1 over a to the power of b. And then when we multiply that, that just gives us 2 over a to the power of b. And that's how you need to think about it. This 2 is just being multiplied by a to the power of minus b. So all you need to do is just put this in brackets and deal with this individually, because that's all the rule states for. The rule doesn't state what happens when there's a coefficient. So this is our final answer. And just quickly to mention that we multiply these 2 terms by thinking of the 2 as being 2 over 1. So this would just be the same as 2 over 1, and then top and bottom gives us this as our final answer. Hopefully that makes it a little clearer for how we go about these questions, just making sure to separate this off and only apply the rule to what the rule states, which is this. The rule doesn't take into account for coefficients, so you only apply it to this, and then again once you've solved it, it's just like 2 multiplied by, and then the brackets would be around here, so 2 multiplied by this gives us this. So once you have a go of this, make sure and you understand watching this video, make sure to just do a couple of the practice questions, and then you can look at the indices. And in the next lesson, or even in indices 2, we'll look over the next 4 rules. See you then.